We're going to integrate 5 cos raised to the power 4 x over 4 dx. Now, to the power 4, we have to split cos to the 4th to be cos squared times cos squared. Since we're going to use the identity I have, open bracket, 1 plus cos 2x. Now we have x over 4 and we can rewrite this as a quarter x if that's the way you're comfortable with it. So this is the identity. Cos square a is equal to a half 1 plus cos 2a, and before we apply it we have to split cos raised to the power 4 x over 4. Now first I can factor out the number 5 outside the integral. In cos raised to the power 4, we have 5 on the outside, integral, then we have cos square x over 4, and then it's going to be multiplied the same thing, which is cos square x over 4 dx. So we have cos square a, in this case is cos square x over 4. So I'm just going to write it above here to show that x over 4 is a. Just look at the position where it lies. We have x over 4. So all of this is our new a. So I would have a half, open bracket, 1 plus, and then a is x over 4. And based on the identity, the cos 2a, where I have 2a, I have to multiply x over 4 times 2, and 2 into 4 goes 2 times. So it's 2 times x over 4, and the 2 into 4 goes 2 times, so I have x over 2. So this is going to be cos x over 2. So all of this is what I will have for the first cos square x over 4. So it's a half 1 plus cos x over 2, and it's going to be the same thing for the second cos square x over 4. So let me go ahead and write. So both are going to be the same because it's cos square x over 4. Now the next step is to expand, and I can say a half times a half, that gives me the quarter. And I'm going to multiply the two brackets that we have here. So I'll be expanding the bracket. That's the next step. So carry out the quarter. So 5 times a quarter, that's 5 over 4. Then I'm going to rewrite the bracket that we have here. So the two brackets, I'm rewriting it. Then I'm going to expand. So the 5 over 4 integral, and then I am going to expand the bracket. So let me write back the 5 over 4 and the integral sign. Now to expand, I'm going to multiply 1 times 1 is 1. Then 1 times cos x over 2, that gives us cos x over 2. Then cos x over 2 times 1, that's cos x over 2. And cos x over 2 times cos x over 2, that's cos square x over 2. So just to ensure you got the expansion, we multiply 1 times 1. That gives me 1. 1 times cos x over 2, that gives me cos x over 2. Cos x over 2 times 1. And then cos x over 2 times cos x over 2 is cos square x over 2. Now the center can be added because they're similar. So therefore, well, they're the same. So therefore, I'll have 2 cos x over 2. And we can rewrite the remaining. So we add these two plus cos square x over 2. Now, the cos square x over 2, I have to apply the identity again to get rid of the square. So the identity is cos square x is equal to a half, open bracket 1 plus cos 2x. So in this case, we have cos square x over 2. So we're going to apply the identity to this. So cos square x over 2 is equal to a half, open bracket 1 plus, and multiply x over 2 times 2. That's going to give me x. So therefore I would have cos x, because x over 2 times the number 2, the 2's cancel, so I'm just left with x. So right here I write plus a half 1 plus cos x after applying the identity to the following. So I have a half 1 plus cos x. Now multiply a half times 1 and then a half times the cos x. So that's our next line. So I'm going to write everything as is and expand the bracket that we have there. So a half times 1, that's a half. And a half times cos x, that is half cos x. Then we have our dx. So now we are going to add 1 plus a half, that gives us 3 over 2. And now we're going to integrate. So the integral of 3 over 2, that's 3 over 2x. The integral of this, 2 cos x over 2. X over 2 is like a half x. So when I integrate this, it's going to be 1 over a half. And when you integrate 1 over a half, you're going to flip the fraction. For example, if you integrate cos 2x, we know it's a half sine 2x. Or put the 2 to be 1 over 2. So if I have the integral of cos x over 2, which is the same thing as a half x, then when we integrate this, it's going to be 1 over a half sine half x. But when we have a fraction in the denominator, we know that we are going to reciprocate it. So it becomes 2. So in other words, what I'll have here is 2 sine x half x. So it's 2 sine half x plus integral of cos x is sine x, so I'd have a half sine x, and I have my plus c. Now 2 times 2, that's 4. So I have 5 over 4. And then rewrite everything 3 over 2x plus 4 sine half x plus half sine x plus c. Don't forget to like and subscribe to my channel. Have a great day.